Hello guys, good morning. Welcome to my channel Chemical Diary. Last video I have posted about the manufacture of sulfuric acid by DCDA, double contact double absorption process, and from the viewers they asked me to explain about the operating condition of sulfuric acid. So according to them, today I am going to post the video for them about operating condition. So before going to explain you about the operating condition, I would like to revise the process of sulfuric acid production, DCDA. So let's start. DCDA, first of all I would like to explain about DCDA, double contact double absorption. Why it is called double contact means when the gas go to first bed, second bed, third bed, after third bed again it go to fourth bed, and after fourth bed it go to intermediate absorption tower. After intermediate absorption tower, again gas go to the converter fifth bed, again after fifth bed it goes to final tower. So it means double contact double absorption. So this is the meaning of double contact double absorption process. So you have understand and learn about the definition. Now let's start from the beginning, from where the sulfur start and where it's end as sulfuric acid. So we get sulfur, and the if we got liquid sulfur, we can directly put a liquid and we can use it. And if we don't have liquid sulfur, then dry sulfur will come here, and it get melted. In dirty pit we maintain temperature, if there is a liquid sulfur, we maintain temperature around 135 to 130 to 135, and pressure we use as LPS, low pressure steam. And if there is a liquid sulfur, just to maintain the temperature we use LPS steam. If we have solid sulfur, then we need MPS steam, medium pressure steam, so that we can melt the sulfur in less time. Though you can melt the sulfur in with the help of LPS steam also, but it takes more time. So that is why we have provision of LP steam and MPS, medium pressure steam, high pressure steam. Okay dear. So from here dirty sulfur it go to filter, and from filter after cleaning it go to molten pit. So we have sulfur pit here. In sulfur pit we maintain temperature about 130 to 135. At this temperature sulfur remain in liquid state, because after below 100 degree it will be converted to solid. But here with the help of pump we will transfer here, and it should get sprays as per the process. So that is why we have to maintain the sulfur in liquid form. So after that, at 135 degree temperature sulfur goes to furnace. We maintain furnace temperature around 1000 to 1050 degree. This is the good condition and favorable condition. We have to maintain temperature around 1000 to 1050 degree, so that sulfur sublimation should not take place. We maintain this temperature 1000, we should maintain. And you know that auto ignition temperature of sulfur is 444. It means that if sulfur is more than 444, we does not need any type of fuel to combust the sulfur. You know that for combustion to take place, it's we need a fire triangle. Fire triangle is nothing but oxygen, fuel and air. So we have air, this is with the help of blower. We have air, and we have a furnace, we have fuel also. But what we need, uh, we need temperature. So this is the temperature. So at high temperature it get combustion take place. After here we have temperature around 1000 degree. So but in converter we need temperature around 420, more than 420. So that is why we send the gas, to the waste heat boiler, so that we generate steam, and this steam is used to generate steam turbine, and that turbine is used here. for the production of air. First time we use startup blower, and once we reach the we get the pressure in steam turbine up to 60 kg per centimeter square, or 40 or 30 or 25 kg per centimeter. These all pressures and depend upon the design of the turbine. So once we have the steam, then we will change over this to steam turbine, and with the help of steam turbine we run this plant. So this blower is used only for the first time when we don't have temperature or pressure at that time. After that, from the waste heat boiler, we reduce the temperature to up to 420. After that, it goes to converter, first bed, and from first bed it goes to heat exchanger. And after when it goes to first bed, we have vanadium pentoxide V2O5 catalyst in the converter bed. So when it go to first bed, it temperature increases. So when temperature increases, we send to heat exchanger, so that it reduced to 420. So it go to second bed. Once it go to second bed, again its temperature increases, because this reaction releases heat, so that is why temperature increase. So after second bed, again we send to heat exchanger, again we bring down to the third bed. After third bed, again temperature increase, again we send it to heat exchanger. After third bed, again we send to fourth bed, again temperature increase, and again after heat exchanger we send it to oleum tower, or intermediate absorption tower. So we send to intermediate absorption tower. After that, again gas goes to fourth bed, and from fourth bed again temperature increase, again it will go to economizer. From economizer, it go to final absorption tower, and after final absorption tower this goes to the after scrubber. In scrubber we have caustic solution prepared, in which SO2 gas, if remaining traces amount or 1 or 2% SO2 gas which does not scrub in final tower or intermediate absorption tower, it will go to scrubber. So it react with caustic. So the SO2, remaining SO2 will very less amount of will go to the plant stack, and remaining whatever the we get the neutralized solution, it will go for the wastewater treatment plant. So this is about the gas. Now I'm going to explain you about the acid. We have common acid pump tank. So this tank will send acid to the final absorption tower, intermediate absorption tower, and drying tower. So and this is the drying tower. So all the acid get drained from the acid tower and will get collected, and with the help of pump, acid will go to the drying tower, intermediate absorption tower, and final tower. So acid gets sprayed from the top of the tower, and from the bottom gas goes. So this is so when SO2 convert to SO3 in converter, it goes to the absorption tower, where SO3 react with H2SO4 to become concentrated acid. After that, water is added, that is called dilution water, to reduce the strength of acid. After adding water, its strength reduces, and once we in sulfuric acid, once we add the water, so its level increases. So some of the acid is transferred to the storage as a product acid. So this is how we produce sulfuric acid. Now I'm going to give you operating details of this plant. So first of all, in sulfur melter we maintain temperature about 130 to 135, and we uses MPS, medium pressure steam. After that, from it overflow it go to sulfur tank, or if the quality of sulfur is not good, then we send this sulfur to the filter with the help of control valve. After that, it go to sulfur tank, in which we maintain temperature around 130 to 135, and with the help of sulfur pump we send sulfur to the sulfur furnace, in which there is a section that is called BMS, burner management system, in burner management system, it takes automatically the flow rate of sulfur and flow rate of air. This PMS manage the ratio of sulfur and ratio of air. If low air, it will increase the sulfur by it decrease the sulfur. If sulfur is high, it increase the air. So depending upon this flow ratio, we have here controllers. Burner management system, its main function is to maintain the exact ratio. If air is less, sulfur sublimation take place. If air is more and sulfur is less, then the furnace temperature reduces continuously and combustion will not take place. So for this reason, to maintain temperature around 1000 to 1050, we have PMS, and PMS cost you more. And if you don't want to have PMS, then you must know the calculations of the sulfur furnace, that how much air is required and how much sulfur. For example, just a blind fillet, I'm going to explain you that without BMS also we run the plant basing on the temperature. For example, we maintain the temperature of furnace 1000. So when I'm adding sulfur, it temperature increases. So once temperature increase, what I will do, I will increase the air. So what happened, quenching take place, then furnace temperature remain constant. So once you increase the sulfur, then furnace temperature increases, then increase the flow rate of air, then furnace temperature reduces. It means that exact you are getting appropriate amount of oxygen and appropriate amount of sulfur. So this is how we maintain furnace temperature. We should maintain furnace temperature of about 1000 to 1050 degree. And you know that, so when sulfur react with oxygen, it produces heat is released. So that is why this furnace temperature is maintained because of combustion. I'm going to explain you about the reactions. See, S plus O2 SO2. This reaction takes place in furnace at the temperature 1000 to 1050 degrees centigrade. Whereas, and this reaction release heat, and after SO2 plus half O2 give SO3. This reaction take place in converter in the presence of V2O5 vanadium pentoxide catalyst, and the temperature we maintain about 420 to 425 inlet of the converter inlet, and outlet would be 520 to 525. It means delta T. Delta T is 100. It means 100 degree temperature is raised. Whereas SO3, when from converter the reacted gas will be SO3. SO2 react with SO2 become SO3. Then SO3 react with H2O to give H2SO4 in absorption tower, and we maintain temperature around about 70 to 74. H2, this is H2SO4, not H2O7. H2S2O7 is oleum. H2SO4 sulfuric acid. So this is about the reactions, and this is about the temperature we maintain. Now let's proceed for the furnace. I'm going to give you details about the furnace. So when continuous combustion take place, we maintain the temperature. But for example, when you are going to start the plant for the first time, at that time, but as per the sulfur, as per I mean to say that, we know that auto ignition of sulfur is 444, and we need 1000 degree to if we have 1000 degree, then only we will burn sulfur for a good combustion. So how we achieve this temperature before burning for the first time? For the first time, we will use fuel gas. And with the help of fuel gas, we have startup blower. So we will use this blower, and we use fuel to burn the and we have the igniter also. So when you press the igniter button, and when fuel gas goes and where air goes, ignition take place, and slowly we increase the temperature to 50 to 100, then 100 to 150, 150 to 200, 300, and slowly we take temperature up to 1000 degree. And you know how we raise the temperature by step. depending upon the refractory, the refractive end, the person who arranged this refractive brick inside, he will give us the holding time for the brick, so that if we increase the temperature suddenly from 0 to 100 and 100 to 500, the brick may get crack. So for this reason, we should maintain the temperature slowly. So we will have the heating curves, that's called heating curves. According to the heating curve, we heat the furnace with the help of fuel gas. And if your plant is very small, or your plant is not a petrochemical plant, and if you don't have fuel gas, then the another best option is using diesel firing. You can bring diesel with the help of tanker to the tank, and with the help of tanker, you can arrange one pump, and with the help of that pump you can spray diesel using spray burner. Diesel will be sprayed, and uh, igniter will give you the ignition, and after the air will introduce, and continuous combustion take place. So when combustion take place, it increase the temperature. So after so temperature gets slowly increase. So this is how we have to increase the temperature for the first time. So just now I have explained you about the operating temperature, as well as how to start the plant for the first time also. So once after that, let's go to the process, operating procedure. So after this temperature, we have 1050 temperature, or 1000-degree temperature. This temperature is too much for the converter, because in converter our aim is to have the temperature range between 420 to 420. Why? Because all the temperature range we should maintain about below 420, not higher. If we maintain temperature higher, our catalyst may get damaged. So that is why the favorable temperature for catalyst is to maintain temperature around 420. So that is why we send the gas to waste heat boiler, and in waste heat boiler, when 1000-degree temperature will go, in this we have water. In from the tubes the gas will go, and in the shell water will be there. So water is when water get heated at 1000-degree temperature, it will generate steam. So steam will go to turbine, and this turbine is used to this here steam will go to the turbine to run the turbine. For the first time, we use this startup blower to raise the temperature. Once we reach the 1000-degree temperature, after that what we will do, we will change this to turbine, and we use this turbine to run the to run the air through this furnace. So first time we are using startup blower. Once we generate steam, this steam is used to run the turbine. So this is a very economical plant. Why? Because uh, this process releases heat, and this heat is used to generate steam, and this steam is used to generate turbine, and after turbine again the remaining pressure will go to again turbine, and after this go to small turbine, and that turbine the turbine rotation will be used to generate electricity, that is used for the cooling tower of this and cooling tower, and that cooling water which go to the PHE for the cooling of acid. And the steam from the turbine 1 and turbine 2 will have pressure around 4 kg or 6 kg, that will go to pressure PRV, pressure reducing station, PRS. And pressure reducing station will convert the pressure and reduce the pressure into MPS and LPS. So MPS is pressure will be given to the in case of if we get dry sulfur feed. In case of liquid sulfur we get from the company, then we will use LPS steam. So steam is generator, so this waste heat is used to generate steam, that is useful for generating the turbine, and this turbine gives air which we will send it to the furnace. So it means we are saving electricity to run this plant. So this is very useful plant. So after waste heat boiler we get temperature. So this is the converter. After converter, again third bed, and this is intermediate absorption tower and final absorption tower. And whatever the gas, tail gas will be goes, such as composition will be O2, amount of O2, N2, SO2, SO3. When SO2 react with O2, it will become SO2. So what in air, that mainly we have 21% uh, oxygen and 79% nitrogen and inert gases. So that is why we will have the flow of gases, and but in that oxygen percent very less because oxygen is consumed. So maximum will go nitrogen and some amount of SO2 and SO3 and inert gases. So these are the tail gases. Okay dear, there's operating conditions. We maintain furnace temperature about 1000 to 1050 and sulfur melter temperature around 130 to 135, and intermediate absorption tower or final absorption tower acid temperature or drying tower acid temperature we maintain up to 70 to 75, and gas inlet to acid tower we maintain up to 180 to 190. The temperature of the gas should be more. Why? Because condensation or mist formation should not take place. That is why we maintain the temperature of the gas more. And heat exchanger temperature as per design, and our main aim is to maintain the temperature of the bed, and acid flow will be depend upon the design. For example, that this amount of gas is going to the absorption tower. So if this x amount of acid gas is going, then y amount of acid will be calculated, and that much amount of acid will be spread on the tower. Maybe 100 meter cube per hour, 120 meter cube per hour, 300 meter cube per hour, and 400 meter cube per hour. This all depending upon the production of SO2. If SO2 production is more, then it is inversely proportional, directly proportional. If SO2 concentration is more, then acid concentration flow will be more. And we maintain acid concentration as 98.5 and oleum tower temperature we maintain as 42. Now let's go to the operating condition of the beds. This is the converter. We have first this is the bed 1, bed 2, bed 3, bed 4. So gas come to the bed 1 and it go to heat exchanger, then bed 2, then go to heat exchanger, then go to bed 3, then go to absorption tower, and coming back it go to heat exchanger to get heated, and again it come to fourth bed. From fourth bed maximum we receive up to 99% gas SO2 will get converted, and only 1% unconverted will go to tail gas, or I can say that scrubbing tower. So inside of the catalyst, these are the support in which we put the catalyst. And first we will have ceramic packing. After that we will put ceramic packing, or some of them use the glass balls also. So it is depending upon the design of the plant. So after ceramic packing, V2O5 catalyst will be kept. After that ceramic packing, then ceramic packing in second bed, then catalyst, then ceramic packing in third bed. Also ceramic packing or glass ball, or V2O5, then glass ball or ceramic packing depending upon the design and cost of the plant. Okay, inlet to the first bed will be 415 to 425, we have to maintain the temperature, and outlet will be 550 to 600, and inlet will be 420 and outlet will be 600 650. We got temperature up to 650 615. So this temperature is high, we cannot send this gas to the third way. That is why we send this gas to the heat exchanger. In heat exchanger what happen, the temperature will get reduced and it will come. For example, when gas coming from the intermediate absorption tower, the temperature of the gas will be 70 degree. So in heat exchanger, one gas will have temperature of 70 degree, and one gas stream will have temperature 615. So the gas which is having 70 degree, it goes to exchanger 1, and it temperature increases up to 300, and this 615 temperature reduces to 400, and again we have temperature here 550 to 600. So again this temperature go to another exchanger too, in which the gas temperature is 330, it goes to 420, 470, and the this temperature reduces. This is how we exchange the temperature. So fourth bed will have 420 and 470. This is one of the plant in which bed temperature we maintain like this. I have other plant in which we maintain temperature like this. First bed inlet is 400, outlet is 600, and second bed is 450, outlet is 520. Third bed is 450, 475. Fifth bed is 420 and 540. So you know that why this temperature changes. Here we have 550, but here we have 600. Why? Because these things, it's all depend upon the catalyst you added. If in the first bed if you added more catalyst, then more reaction take place and you will have high temperature. And if you take more catalyst in third bed, here reaction take place and high temperature. So we kept this catalyst in different types of bed to manage the temperature of the plant, so that we can easily quench the temperature. If we kept all the bulk catalyst at single, then it's very difficult to control the temperature. So that is why we use different types of exchanger and waste heat boiler or steam drum and economizer to reduce this temperature, and we utilize this temperature to distribute the heat or to maintain the heat in the plant, and also to generate the steam, which in turn is useful to generate the electricity. This is the absorption tower. Inside the absorption tower we will have packing. These all are filled with ceramic packing, and from bottom gas will go like this and will go here, and here this is called acid distributor, in which acid get distributed properly. So acid and gas in the ceramic packing mix well, very well. After that it goes to the dry gas. The gas, remaining gas will go to here, and here we have mist eliminator or filters. So when it goes to the filter, whatever the acid mist or acid is carrying with the gas will get plug here and will fall down continuously, and dry gas will go to the fourth bed. So guys, this all are about the operating conditions. So I have mentioned clearly that how much temperature of the furnace we have to maintain, and how much temperature in the beds. So some plant use some plant have 400, 420 inlet and outlet as 520, whereas some plant has inlet as 420 and outlets as 625 or 630. This all because of how much catalyst you add in the beds. So the temperature on operating conditions are always depend upon the amount of catalyst you add. So this all these things are calculated as per plant cost and plant design and plant space. So everything is designed and according to the catalyst and according to the raw material and according to our production rate. All these things are calculated, and basing on those calculation we keep the catalyst amount of catalyst in the different beds, and that also decided how many beds we need, and all these things will be decided, and thus we maintain the temperature. But make sure that whether the plant is 100 100 sulfuric acid ton per day or 1000 per day or 3000 per day or 300 per day, but the main thing is that the inlet temperature the catalyst will be maintained above 400, above 420. So this is the main criteria to maintain the temperature. So operating condition is only just we have to maintain the temperature. Okay, one more thing I would like to explain you that if our plant gets stopped and we wanted to start again, if the furnace temperature is not 1000 at a time, what we will do? So can we start the plant? Yes, we can start. We know that the sulfur autoignition temperature is 444. So if we have temperature up to 1000 also, or below 900, below 800, or below 700, also we can start the plant. So once you start sulfur firing, then furnace temperature will increase slowly. So once one furnace in temperature increase, then definitely it will go slowly to 1000 degree temperature like this. So we can start the plant because we know that auto ignition temperature of sulfur is 444. Below 444 you cannot start the plant because sulfur will not get ignited, and the sulfur pooling will take place, and this sulfur, when we go to the waste heat boiler, this damages these tubes, and plugging take place, because here condensation take place in this line. After that, the sulfur will go to catalyst, and these catalysts will get damaged, and after that, when it goes, sulfur will go to absorption tower. All these candles will get blocks, so it's very difficult. And lastly, I would like to add that all this plant is either automatic or semi-automatic or valves. If you have a good if you want your plant to be advanced, then everywhere you can put control valves. For example, if from we have here exchanger. So if we put TIC, temperature in the controller, and we put here the TIC third bed temperature 420. If temperature is more, the control valve will open and will send the gas to the exchanger. If temperature is less, it will not send the gas to the exchanger. In turn, it will go bypass. So this all depend upon the control valves that you maintain. And if you don't wanted to have the plant automatic, then you will use the manual valves to control the bed temperature, and bed's temperature, and acid temperature. And if you have TIC, PIC, LIC, and all those controller, then you need not to have operating valve or the manual valve for this. So if you have automatic plant, less manpower will take place. So I'm going to end this video. I'm very happy that you have asked me about the operating condition. I've explained you well about the operating conditions and different types of temperature and different types of bed according to the production of the sulfuric acid and according to the raw material of sulfur availability. So this is how we maintain the operating condition, and this is how we maintain the sulfuric acid strength, and we produce the sulfuric acid by DCDA. Thank you. Please subscribe to my channel. Thanks.